Okay, let's take a look at problem 2, graphing a tangent function. It says sketch 2 cycles of the graph of y equals tangent pi theta. Okay, and so, of course, to find the period, we need pi over b. B is my coefficient of theta, and by the way, all of this information is right here in this beautiful chart. Okay, and I get 1, and I know one cycle occurs from negative pi over 2b to pi to 2b. And so I am going to divide this basically in half, divide my period in half. So I get negative 2 pi, which is going to give me negative 1 over 2 to 1 over 2. And so I'm going to add one more period to this, so just adding 3 over 2 gives me my third period. And so I'm going to cheat, and please feel free to cheat also. I'm going to use my free graphing calculator at www.desmos.com. I'm going to plug it in. So I'm going to do y equals, I'm going to use my function here, tangent, and I'm going to put pi, and I'm going to put x. Okay, and that's a lot, right? Well, we don't need all of that. Let's put in our boundaries. Our boundaries are from, these are our asymptotes actually. X equals negative 1 over 2. X equals 1 over 2, and x equals 3 over 2. So those are our boundaries. And so this is one cycle, and this is 2 cycles. So this is the only part of the graph that they're asking for. Okay? Also, really good to know. So just like we do it with cosine and sine, we can use the asymptotes and 3 points to sketch one cycle of a tangent curve, as is with sine and cosine. The 5 elements are equally spaced throughout one cycle. Use the pattern asymptote, negative a. And remember, a is my coefficient of my term. For this one, a would be 1, right? So it would be asymptote, negative 1, 0. Then I have 1 into my asymptote, all right? All right, so, okay, let's try it on our own now. So we have sketched 2 cycles of the graph of each tangent curve. So first, let's look at our period. So we have tangent of 3 theta, and so period is pi over b, and so we have pi over 3. Cycle is going to be negative pi over 2b to pi over 2b. So I get negative pi over 6 to pi over 6. And those are my asymptotes. If I want to find out the next one, I can just add pi over 3 to this pi over 6. And that's going to give me, sorry, not equal, let's see. So that's 2 pi over 6 plus 1 pi over 6, which is going to give me 3 pi over 6, which is really pi over 2. So the next asymptote will be pi over 2. Okay? So let's, and I'm going to have to do a little extra cheating for this one, because I have not figured out how to, I'm going to put this one here because it already has the pi. Alright, so I already have 2 pi, negative pi, 0 pi. So my x has, I already have intervals of pi. And here in my settings, I see that it's labeled not with pi, but with decimals, but these represent pi. Okay, so let's graph it now. We have y equals tangent 3 theta, so we're going to use x, of course. Tangent 3x, right? And they want it on an interval of 0. So we want to start, oops, sorry. I want to start here at 0, so I can move this over if that helps. So starting here at 0, that's where I'm looking at. So this one actually gets cut off to 2 pi over 3. And we can find that. X equals 2 pi divided by 3. So there is one of my, that's my barrier there. I know we could put another barrier, y, sorry, x equals 0. So those are my barriers. Let's put some asymptotes there now. And we said our asymptotes were negative pi over 6. We don't even need negative because it's starting at 0. So let's put pi over 6 instead. X equals pi divided by 6. So there's one asymptote. And x equals pi divided by 2. There's another asymptote, and that's the last one because this is my barrier right here. So from the green to the blue is my barrier, and that's what they wanted. So everything else is not needed, right? So I'm just having this little half, then I have this, and I have, so I can zoom in also. Oops. So there's everything that we need right there. Alright, so from 0 to this blue line is all they asked for, so that's just half of that, one full, and then this bottom half here. So I hope that this helps. Sorry about that, I forgot to do part B. Okay, so we're not done yet. Let's go back. Let's get rid of this. Okay, and we don't need this anymore, so we need a new blank graph. Okay, so we want tangent pi over 2x. Let's go ahead and graph it. We'll put the boundaries in. Pi divided by 2x. So there's that graph. Now let's put our boundaries in. So we want it from 0 to 4. So let's go ahead and put that boundary in. So x equals 0 and x equals 4. So this is all I want of it, right? From here to here. That's all they asked me to graph. Now let's find out the asymptotes. So we can find the asymptotes by finding the period, and I need my whiteboard. So period would be pi over b. My b is pi over 2, so it's going to be pi over 2, which is pi times 2 over pi, which is 2, right? And so half of that would be 1, so it'd be negative 1 and 1, but let's work it out. So we have negative 2 pi, 2 pi over 2, and so we have negative pi over 2 times pi over 2. We can go ahead and get rid of that, which is going to give me negative 1, and then I have pi over 2 times pi over 2. That cancels out, and we'll put pi over pi, which is 1. So period or the interval from negative 1 to 1. Those are my asymptotes. And I can find one more by adding 2 to that, which is 3. So 3 is another one. So negative 1. But we don't need the negative 1 because I believe our interval is, yes, 0 to 4. So we don't need the negative 1. We won't graph the negative 1, but we will graph the 1 and the 3. So we'll see those asymptotes. So let's put them on our graph. 1 is one asymptote. X equals 3. There's the other asymptote. And we don't, I mean, the asymptotes are really invisible lines. They're not really there, but they help us to see those boundaries of. So we know that this graph is getting closer and closer and closer, closer and closer and closer to this one, and it goes through the 2, and then it gets closer and closer and closer to this boundary, and so on and so forth. And this one as well. It gets closer and closer, but it doesn't touch it. So it just kind of helps us to shape it. It doesn't, it's not really there though. So it's just the boundary. And I hope this helps.